Hello, St.Thomas.
Yes, miss.
Am I audible to you?
Yeah, audible, ma'am. Uh, Good afternoon, everyone. Can we start now? Continue. Okay. Okay. So let's begin the session. Good afternoon to one and all. Welcome everyone. Thank you for joining us for today's webinar, AI, a new era of transformation, organized by Department of Computer Science and Engineering, St.Thomas College of Engineering and Technology, Kannur. It's my great pleasure and honor to welcome our resource person, Nithin Prince John, our respected principal, Dr. Shinu Matthew John, our CEO, Rijo sir, Anita ma'am, our academic coordinator, HOD of CSE department, other HODs, my colleagues, and all my dear friends, students, and other participants to this webinar session. Now I invite our respected principal, Dr. Shinu Matthew John, to speak a few words. Sir, please.
Am I audible?
Yes, sir. Audible.
Yeah. Respected CEO, Mr. Rijo Thomas Joss, today's resource person, Professor Nithin Prince John, Assistant Professor, St. Git College of Engineering, Kottayam, Professor Renji, Department Head of CSE, Professor Anjida, this event coordinator, teaching non-teaching faculty members, and my dear students. I'm extremely happy to be in this particular program. And I appreciate CSE department for organizing an event like this because I was aware about each and every activities you have organized to make this function a grand success. That all activities were appreciable. All of a sudden, we know that around 1.5 years back, lockdown declared, and we were compelled to be in our homes. That time, we were unaware how to proceed the basic teaching learning activities. So that time, we faced several challenges. The first is pre-recorded videos, then assignments we have given to students. That time we started thinking of taking online classes. We were totally in dark, but confidently I can tell after 1.5 years, now in a systematic way, the teaching learning process successfully we are conducting or continuing. The next thing we have to consider our co-extracurricular activities, and we missed our tech first, we missed our arts, we missed our sports. So online sessions, I know that these online sessions are not equivalent or good enough as our offline sessions. But I believe that in the coming months also, we have to continue like this in order to control this COVID virus. It will take a few months more. So for that much time, we have to do something on core and extracurricular activities. All of a sudden, we had a discussion with the faculty members and the students, and we started organizing our tech first as well as cultural programs. So as a part of that, we are starting with some webinars. Later on, cultural activities also will be starting. Students, I request you to forward your suggestions. Last week, we had an HOD meeting. In that, we discussed the things in detail, and HODs and the staff representative will talking to you. See, all of a sudden only we are creating all these activities. Because of that, some dissatisfaction may come from different corners. In that case, we have to discuss together and resolve the issues. When we are coming back to our session, today's expert talk is based on artificial intelligence. When I was a student, I studied this particular subject. So that time I was unaware about the application of this artificial intelligence. Right now, see, artificial intelligence is the current trend. A lot of applications are there. A lot of things we can predict by means of this artificial intelligence. See, this artificial intelligence is nothing but we are training machines and computer to think like human beings. Especially our problem solving and decision making capacity, we are training the computers and machine to absorb this capacity, that is artificial intelligence. The remaining thing you will be getting from our resource person. Once again, I take this opportunity to invite Professor Nithin Prince John to this session and appreciate computers department as a whole for organizing events like this and handing over my session back to Professor Anjita. Thank you.
Thank you, sir. Thank you for your words. Next, I would call upon our CEO, Rijo sir, to address this function. Sir, please.
Thank you, Anjita. Am I audible?
Thank you. Yes, sir. Audible.
All right. So, respected principal, the program coordinator for this webinar, Anjita Miss, the department head at NGMS, other faculties, and more importantly, the resource person for today, our esteemed guest, Assistant Professor Nithin Prince John, and to all our students. A very warm good afternoon to all of you. See, this session is one of the most hotly contested topic in tech world, in your social life and all. So I hope this session gives you an overview as to what is artificial intelligence, what all are the current trends in artificial intelligence, and what is going to be the future direction of artificial intelligence, because this is a topic which evokes a lot of positive as well as negative comments from a lot of viewers actually. So there are ways in which we have already seen where artificial intelligence helps us in our daily life. And conversely, on the other side, there are a lot of government regulators and your free thinkers who think the extent of artificial intelligence and the influence of it is hampering our society, and there might come a time where machines will be dictating human life as it is. So it's a very widely contested topic, and it's a very widely contested area of development actually. So I hope this session provides you very brief insight, because you can only have a very brief insight with just one session. So hopefully you can gather what is being taught in this webinar. You can have an insight as to what is AI and how it is going to proceed forward. And some of you may get interested in this topic, and you might choose AI to be your area of expertise. So make sure you use the knowledge of the resource person who's gathered today to pick his brains regarding all these aspects. And once again, I would like to congratulate CS Department for organizing such a program. And hopefully, and I welcome Nithin sir on behalf of St. Thomas College for taking a valuable time in terms of organizing such a webinar on a wonderful topic. Thank you.
Thank you, sir. Thank you for your words. Now, I would like to invite Renji ma'am, HOD Department of Computer Science and Engineering, to address the gathering. Ma'am, please.
Good afternoon and a hearty welcome to one and all. Today, the Department of CSE, St. Thomas College, is hosting the first webinar in our webinar series that follows in the coming months. And I'm happy to have with us an eminent speaker, Professor Nithin Prince John, an expert in the area of artificial intelligence. I thank you, sir, for spending your valuable time with us to share your knowledge, especially for the benefit of our students and faculty members. I also appreciate the efforts taken by the organizers of this webinar, Department of CSE, both teaching and non-teaching staff, especially the coordinator, Professor Anchita K, for selecting a knowledgeable resource person to deliver today's talk. I hope all the students and faculty members in and out of STM who have joined us today will be benefited by listening to the webinar for the next 2 hours. So thank you, and once again, I welcome you all to this webinar. Thank you.
Thank you, ma'am. So now we are delighted to have our resource person, Nithin Prince John, Assistant Professor, St. Kitts College of Engineering, Kottayam, Kerala. A few words about our speaker. He had completed his MTech from University of Kerala and BTech from CUSAT. He had won Best Paper Award in the IEEE International Conference on Circuit, Power and Computing Technologies. He had won first prize in line follower competition during CEC Summit 14 held at College of Engineering, Kannur. He had also secured second highest mark in BTech degree examination of CUSAT in April 2013. He was the research team member of Leading India.ai project from April 2018 to present. He also worked as research sabbatical in NVIDIA Bennett Research on AI at Bennett University, Greater Noida. He also worked as assistant professor in Kottayam Institute of Science. He is delivering expert talks on artificial intelligence, deep learning, machine learning. Also, he is providing hands-on sessions on these topics. Also, he has been invited for various FDP programs across the universities in Kerala. He had published his research works in IEEE journal. Also, he is a life member of Indian Society for Technical Education and International Association of Engineers. So, with great pleasure, I invite Nithin sir to start the session, and we are very happy that you are here to share your knowledge with all the members in the session. Thank you, sir. Once again, welcome to the session. Over to you, sir.
Thank you. Thank you, ma'am, for your nice introduction. Am I audible, right?
Yes, sir, audible.
Okay. A very warm good afternoon to one and all. And it's my immense pleasure and privilege to be here to deliver a talk on the topic on artificial intelligence, machine learning, and deep learning. Firstly, I take this opportunity to thank the management of the college for inviting me to this session. This is the public notice regarding the usage of images in the upcoming slides, and these are considered to be covered by the doctrine of fair use. So let me start our session with a quote by Victor Hugo. There is nothing more powerful than an idea whose time has come. You may ask, what's the relevance of this quote in this meeting, right? So here the idea means it's artificial intelligence and the time is right now. So it's the right time to study about artificial intelligence and its associated field. As we all know that AI is one of the hottest field and there are a lot of opportunities in this domain. But at the same time, AI is overhyped and underhyped. That means for some problems we can solve really well, and there are some other problems that are just out of the reach right now. One of the leading researchers in this field, Professor Andrew Ng, calls AI as the new electricity. Why it's so? Because when electricity was invented, it transforms every aspects of our life, ranging from transportation, medicine, industries, and so on. Likewise, AI is going to have some impact on all these industries. Then what exactly is AI? In layman terms, we can say that whenever we teach the machines to think like humans, we can call that class of technologies as AI. Or in other words, we can say that it can be any technique that enables machines to mimic their human behavior. One of the best example of AI device is the software robot. As we all know that software robot is the first humanoid robot to receive the citizenship of any country. She uses different technologies like facial recognition systems to identify faces. She can imitate gestures. She can respond to certain queries. Likewise, so many features are incorporated in software. The next example of AI device is the Amazon Alexa, which is the personal assistant developed by the tech giant Amazon. We can directly interact with Alexa. Likewise, if I need to know the temperature of my house, then I need to give a query like this: Alexa, what's the temperature now? Then Alexa would reply with the current temperature. This device can be connected with IoT to control all our home appliances in our house. But in order to activate this device, we need to call it as Alexa, otherwise it won't invoke. The field of AI give rises to a number of cognitive technologies. Cognitive technology means they all are brain-based technologies. These are some of the field. First field is the computer vision area. Computer vision means whenever we teach the machines to see, then we can call that class of technology as computer vision. Okay, whenever we teach the machines to see, then we can call that class of technology as computer vision. The next area is the machine learning. Normally, AI problems can be solved using data or rules. But when we use data to solve AI problems, we can call that class of technology as machine learning. Then the next area is natural language processing, or in other words, we can call it as NLP. In NLP, we are teaching the machines to analyze text. For example, sentimental analysis. It's one of the best perfect example for NLP. After watching a movie, I wrote a review like this: the movie is not so bad. I know that that sentence actually belongs to a positive meaning, but there is a word like not in that sentence. Normally what happens is that this technology needs to analyze all the sentence, all the words in that sentence, and it needs to categorize as whether it belongs to positive or negative review. Okay, this comes under the area of natural language processing. Next is the optimization. Optimization mainly deals with picking up best solution out of the several possible solution. You may have 50 solution, but in that 50 solution, you need to pick one of the best based upon certain parameters or optimization factors. Okay. Next area is the automated planning and scheduling. Planning and scheduling mainly deals with the activity sequences typically for the execution by the intelligent agents like unmanned aerial vehicles and some other robotics field. Okay. The next field is the robotics. Robotics mainly deals with the designing, building, and maintenance of robots. And as we are actually familiar with several type of robots like Sophia, and there are also some other humanoid robots developed by different nations. The next area is the rule-based system. Rule-based system means when we are actually solving AI problems using rules, we can call that class of technology as rule-based system. One of the best example is the doctors may use expert system for diagnosing disease based upon certain symptoms. Okay, and all comes under the area of rules-based systems. And the final area is the speech recognition. Here we are actually teaching the machines to listen. Examples are Apple Siri or Google Voice Assistants, all comes under the area of speech recognition. And there are also some other areas that I'm not going to deal in this session, but these are the common main areas that comes under the field of AI. Okay. Then what exactly is machine learning? In short, we can say that it's the ability to learn without being explicitly programmed. And what do you mean by explicit programming? Suppose I'm giving you a task, write a program to check whether the given number is odd or even. Okay, write a program to check whether the number is odd or even. We know the logic. What is the logic? We can take the number, divide it by 2. If the remainder goes 0, we can say that it's an even number. Otherwise, it's an odd number. Okay, if you know the logic, then you can directly convert that logic into some programs using some of the programming languages like Java or C or CPP, whatever maybe. Okay, we can convert that logic into a program. If we can do that, that type of conversion is called as explicit programming. But here it says that in machine learning, we are not going to do any explicit programming. Then what exactly is? I already told you that when we solve AI problems using data, we can call that class of technology as machine learning. But from this figure, you can find out that AI is the bigger umbrella, and within that, there is an area called machine learning. Machine learning is actually the subset of AI. One of the problem that comes under machine learning is this one. That means given an image, given an handwritten image, you need to write a program that takes this digit as the input, and the system needs to tell what exactly the digit is. Can you write a program for that? That means if in your class you may have around 60 or 65 students, and each one has their own handwriting style, and the 5 may be written by different styles, but the system need to take that 5 and system gives the output. System needs to give the output as it's a 5. Can you write a program for that? It's an interactive session. I just need to have some interaction with you all. It's a question for you. Can you write a program for that? That is, you need to write a program. That program needs to take handwritten digit images as the input, and the program needs to tell what exactly the image is. Actually, it's a very difficult task. Okay, you can't write a program for that. And in that type of problems, you can actually go for machine learning concept. If you know the logic, you can directly convert that logic into a program. But what happens if you don't know the logic? If you don't know the logic, the best idea is that you give the data to the machines. The machines will automatically find out the patterns for you, and it will write a program for you. Here, it says that there is no well-defined function from input to output. If you know the function, then you can write a program for that. But if you don't know the function, then it's very difficult to write a program for that task. Okay. In order to understand about machine learning, we need to know several recipes for that. Okay. One thing is that label data versus unlabeled data. Then what exactly is label data? In short, we can say that label data consists of XY pair. Label data consists of XY pair, where X is the input and Y is called as the label. From this example, you can see some images here, right? So this is the image of 5, and it is stated that it's a 5. Here the label is given as 5. Okay, this is the image of 4, and here again the label is given as 4. So this image is the X component. Okay, this image is the X component, and here the label is the Y component. Actually, we need to give the X component to the machine, and the machine needs to predict what exactly the label for that. Okay, likewise, we have the XY pair. Label data means we have the XY pair. But when it comes to the case of unlabeled data, here Y component is missing. That means we only have this X component. For example, here there are some images of some fruits. We know that this is a banana, and this is an apple. Okay, and we have another banana, but here there is no label for that, or here we are not specifying that this image actually corresponds to banana. But the system does not know what exactly this fruit is. But based upon certain similarities, for example, we know that the color of this fruit is yellow, and here also the color of the fruit is yellow. So all the fruits having yellow color will be clustered together or grouped together. Okay, likewise, based upon certain similarities, it will group the components. Okay, so in unlabeled data, we don't have the label, or Y component is actually missing. We only have the X component. This is the machine learning workflow. Firstly, we need to have the training data. This training data can be labeled or unlabeled. Okay, but in this case, I'm going to take label data. Okay, so I just need to create a machine learning program that will take the handwritten digit as the input, and the system needs to tell what exactly the image is. For that purpose, I need to collect the label data. Label data means I need to have, say, 60,000 or 70,000 images of handwritten digits along with the corresponding labels. So this label data can be directly fed to the machine learning algorithm. Okay, there are several types of machine learning algorithm like support vector machine, random forest. There are so many algorithms in this machine learning area. Okay, after seeing this data, the machine learning algorithm will automatically create a program for you. Okay, after seeing this data, this machine learning algorithm will automatically create a program for you. So this is the program that you are not able to actually write. Okay, but in this case, what this machine learning algorithm will do, it will create a program for you. Otherwise, we can call this program as the learn model. Once you get the program, you can directly give the X component. Here the X component means it's an image. Okay, if you're giving the image of 6 to this learn model or to this program, it will give the prediction as it's a 6. Okay, that's the concept behind this machine learning workflow. Basically, this diagram is divided into two components. One is the training phase and next is the prediction phase. During the training phase, we need to train our machine learning algorithm with the training data. And during the prediction, once you get the model or once you get the program, you can directly take out this program, and to this program, you can give your X component and it will gives you the prediction for that. Okay, I hope that you got the idea regarding this machine learning workflow. Then what exactly data is? As we all know that data contains so many data points. Data points means, for example, if you need to train a system like in earlier case, we need to have so much amount of images. Okay, so say 60,000 or 70,000 images. The whole collection of that images can be treated as the original data. We need to divide that original data into two components. One is the training data and next is the testing data. Training data is basically used for training the machine learning algorithm, and testing data is used for testing data is used for testing the machine learning model. Okay, again, from this training data, I'm going to split that into two components. One is the training data and next is the validation data. You may ask, what's the purpose of validation data, right? So in your colleges, automatically the college will conduct you with some series exam. What's the purpose of that? After teaching the subjects, we need to ensure that whether the students are going in a right manner or not. So in order to know that we are conducting series exams, if they got low marks, then what will we do? We will conduct remedial sessions for that. Likewise, validation data can be treated like this. Okay, it's not the actual test. Actual test is the university exam. Okay, likewise, from this training data, we are going to split that into two components. One is the training data and validation data. With this training data, we are going to train the machine learning algorithm. And during that training itself, we need to check whether the machine learning algorithm is actually learning in a good way or not. Okay, for that purpose, we are again giving this validation data to this machine learning algorithm, and we can call it as a tuning process. Okay, we can call it as tuning process. After the machine learning algorithm learns, it will give you a model. Okay, it will give you a model. To this model, you can directly feed this testing data, and the model gives you the right answer for that. Okay, it may give you with the right answers. Okay, this is the again the workflow. Firstly, you have the training data, and this training data is given to this machine learning algorithm, and this machine learning algorithm will give you the model for you. And after that, you are feeding new data through this model. If the prediction goes wrong, then what do you need to do? You need to again retrain. Okay, you need to again retrain your machine learning algorithm, like the remedial classes that we are actually conducting in our colleges. Okay, if the model is perfect, okay, if the prediction is right, then what we can do? We can directly take out this successful model and directly deploy that model into some other frameworks like a website or whatever application that you are actually interested to develop. Okay, basically, machine learning is categorized into three types. Apart from that, there are also some other categories, but I am not going to deal with all these categories. But mainly here we are focusing on supervised learning, unsupervised learning, and reinforcement type of learning. Okay, these are the main three types of machine learning. Then what exactly is supervised learning? In short, we can say that supervised learning means when we are training our machine learning algorithm with labeled data, we can call it as supervised learning. Okay, when we are training our machine learning algorithm with the labeled data, then we can call it as supervised learning. One of the best example of supervised learning is email classification. When we get a mail, what happened? It can go to spam or not spam category. Okay, so how many classes are there? We have two classes. One is the spam class and another is the not spam class. In the case of handwritten digit, how many images, how many digits are there? We have 10 digits ranging from 0 to 9. Altogether, we have 10 classes. Whenever we give an image, it can be one among these 10 classes. Okay, all these comes under the example of supervised learning. Next is the unsupervised learning. Unsupervised learning means when we are training our machine learning algorithm with the unlabeled data, we can call that class of technology or that class of machine learning as unsupervised learning. Then in that unsupervised learning, we don't have this Y component, right? So we have some documents contain images and some documents contains only text. When we give that type of documents to the machine learning algorithm, based upon the pattern, it will cluster all the documents that contains images as a group, and another group contains the document that consists only of text. Okay, it will cluster the similar documents based upon the text content. And third is the reinforcement type of learning. In reinforcement learning, we have an agent and an environment. This agent is continuously interacting with the environment. Agent is always trying to get some rewards by taking right actions, and it will get some penalty on taking any wrong actions. Okay, one of reinforcement learning is actually used in autonomous vehicles, and in games they are using reinforcement learning as the technology to develop all super style games. Okay, all this comes under the area of this machine learning. Okay, these are the main three areas. Now I am going to tell you about what exactly is supervised learning. In supervised learning, we are actually training our machine learning algorithm with the labeled data. Okay, but this supervised learning can be again classified into two types. One is classification and another is the regression type of problem. Classification means here we have fixed classes. For example, in this case, we have 3 animals. Okay, given an image, the system needs to tell what exactly the animal is. Okay, one among this animal, cat, dog, and lion. Here we have 3 classes. In the case of handwritten digit, we have 10 classes. In the case of email classification, we have 2 classes. One is spam and another is not spam. Okay, that type of problem can be categorized as classification. Another problem is regression. That is again this is again a machine learning task that comes under the area of supervised learning. For example, you need to predict the cost of your house. Okay, the cost of the house can depends upon several factors like the place where this house is located, or whether the hospitals are nearby, or whether the railway stations are nearby. Okay, likewise, so many factors are actually determining to know the price of the house. It can be the square feet, or it can be the number of rooms. Okay, all these based upon the concept of regression. Okay, again, another example is we need to predict the stock price. We know that the stock price can vary. Okay, always it will give you a continuous value. Continuous value means we are not getting some classes. Actually, we don't have some classes here. We only have some values. Okay, that values can range or it can vary, depends upon several features. Okay, this is the best example of regression. Next area is the unsupervised learning. In unsupervised learning, we have another categories like clustering, association, and we have the principal component analysis. In this, I'm not mentioning about PCA, but you can understand about clustering. Clustering means in unsupervised learning, we don't have any Y component. That means the labels are missing. Given these images of fruits, the system will automatically cluster all the red fruits together. Okay, what all are these red fruits? We know that this is apple. Okay, but the system does not know whether this is apple or other type of fruits. Okay, but it will cluster all these red fruits together, and it will cluster all these yellow fruits based upon certain patterns. It will together into one group. Okay, this is called as the clustering type of problem. Next is the association. Association means suppose you are purchasing some laptop from the Amazon, and when you log in to the Amazon for the next time, it will suggest you with the laptop bag. So based upon certain customer behaviors, or based upon some buying patterns of some other customers, it will suggest you with the things. Okay, that's a perfect example of association. So association comes under the area of unsupervised type of learning. Okay, then I'm mainly dealing with computer vision. So what exactly is computer vision? I already told you that when we are teaching the machines to see, then that class of technology has computer vision. Or in other words, we can say that here we are making the computers to gain high-level understanding from images and videos. As we all know that humans have the capability to see this 3D world, right? And we can interpret the meaning from that. But for a computer, it's not an easy task. We have eyes, but for a computer, in order to gain this understanding, we need to deploy cameras for that. Okay, now we know that cameras are everywhere. Okay, in mobile phones we have the cameras, in car system we have the cameras, in house in the home surveillance systems we are using cameras. Okay, in textile showrooms or whatever showrooms, in all these showrooms they are actually using cameras. Okay, so we are getting we are generating lot of data from these cameras. Okay, then can we use this data for machine learning purpose? Of course, we can use this data for machine learning purpose. Okay. But in order to understand the concept behind the computer vision, we need to exactly know what actually an image is. Okay, what actually an image is. And I hope that all of you can see this image. Okay, this is the image of Lena, and this is a grayscale image, right? So in this grayscale image, I'm going to zoom this nose part. Okay, when I zoom this nose part, I will get an image like this. Can you see the small squares here? Can you see the small squares here? Can you reply to that? Can you see the small squares in this area? Okay, these small squares are called as the pixels. Okay, so pixels are the individual units of an image. Please note that pixels are the individual unit of an image. Okay, so for each pixel we have definite colors. For a grayscale image, what will be the value of the pixels? It will range from 0 to 255. Okay, it will range from 0 to 255, where 0 means it's perfectly black and 255 means it's perfectly white. All other values in between 0 and 255 refers to as different shades of gray. For example, if you are getting the values like 127, then it's a gray. Okay, it's a gray. Again, values like 200 or 210, again it's a grayscale image. Okay, so it's a gray color. Okay, in this case, grayscale image has only a single channel. When we look at this image, you can see that it's a gray pixel, right? And the value for that is 134. But when it comes to the case, or when it comes to the darker position, what will happen? It is getting values like 87, 58, 55. That means it is going towards 0. When it is going towards 0, what will happen? The pixel become darker. Okay, so pixel is the smallest unit of a digital image that can be displayed on a digital display device. For representing these 256 values, okay, from if you are counting from 0 to 255, we have altogether 256 combinations. In that case, in order to represent 256 values, we are all are computer science students, right? So for that purpose, how many bits needs to be there? We need to have 8 bits. Okay, with 8 bits, we have 256 combinations. Then when it comes to the case of color, actually this color image comprises of 3 channels. One is the red channel, next is the green channel, and third is the blue channel. Okay, and in this blue channel, 0 means it's perfectly black. Please note that in blue channel, 0 means it's perfectly black and 255 means it's perfectly blue. In green channel, 0 means it's perfectly black and 255 means perfectly green. And in red channel, we have the same condition, that is 0 means it's perfectly black and 255 means it's perfectly red. When we combine these 3 primary colors, we will get the exact color for that. Okay, so we have 3 channels, but in the case of grayscale image, we only have a single channel. Okay, and for representing each channel, for each of these values in this channel, we need to have 8 bits. How many channels are there? We have 3 channels. So altogether, how many bits needs to be there? For representing a pixel in a color image, we need to have 8 into 3, that is 24 bits needs to be there for representing that. Okay, this is the concept behind the RGB image. Apart from this, we have different type of color spaces like HSV. Okay, HSV means hue saturation value. Depends upon your task or depends upon your problem, you can choose whatever color space that you need. But one of the best color space is RGB and HSV. HSV can be used for, I am actually using HSV for developing several type of computer vision projects. Okay, anyway, I'm going to forward the slides. As we all know that AI is the bigger umbrella, and within that we have another area called machine learning. Okay, and within machine learning we have another subfield called deep learning. So deep learning is the current state of the art algorithms, which is completely using in different say products like Amazon Alexa or like Google Voice Assistant. All these technologies are actually using deep learning as the technology. And there is some other area called computer vision. When we look at this picture, we can see that some of the problems in computer vision is actually overlapping with this AI field, machine learning and deep learning. And there are some other problems that do not need any AI technique. Okay, that do not need any AI technique. And we are mainly concentrating on some problems that is actually using machine learning and deep learning. That is, we are concentrating on this area and also on this area. Okay. Why I choose computer vision? Okay, the reason for that is 30% of our human brain is actually devoted to vision when compared to 8% of touch and 3% of hearing. Normally, vision begins with eyes, and it is actually truly take place in the brain. That's why I choose computer vision as my area, and we can develop so many projects in this domain, and this is the best domain to start with AI. Okay. Why is computer vision so hard? It's a question for you. Have a look at this picture for few, say 1 second, or not for 1 minute, and I will ask you some questions regarding this image. Okay, so please have a look. So that's enough. Now I'm going to ask some questions. How many people are there? You can directly put that in the chat box, or you can directly unmute your mic and say something. Okay, I need to have some interaction, otherwise the system will be 7, 6. Okay, that's good. 7. I think that so many students are there in this meet, right? Okay, again 6. Okay, that's good. Anyway, maybe that's good. What are they doing? We know that what they are actually doing. Okay, a person is actually standing on a scale, and he is actually he just need to know the weight. And who is that personality in that picture? Who is that famous personality in that picture? Can you guess that? Who is that famous personality? It's Barack Obama, right? It's Barack Obama. We can identify that. Okay, the next question is that what object the person on the left standing on? It's a scale, right? It's a scale. On that scale, a person is actually standing in order to know his weight. And why this is a funny picture? Why this is a funny picture? Let's count the total number of persons in this image. We have, this is the first person, second person, third person, 4, 5, 6, altogether 7 persons are there. This is the fake person, right? This is the mirror image. So we are not able to count this as a single person. Again, this person is actually standing on a scale, and Barack Obama is applying some pressure on this scale, and he is not knowing about that. And when you see the reading, he is actually astonished about that. Okay, and other peoples are actually watching this, and they are actually laughing. Okay, so many information that we are actually getting from this image. But for a computer system, this is a tedious task. Okay, so first 3 questions can be handled by our current computer vision system. How many people are there? Actually, it will say that 7 people are there by ignoring all the fake persons. What are they doing? With the image capturing technology, they can the system can tell what actually they are doing. Then what object the persons, with the object detection algorithms, the system can automatically find out what all are the main components that is actually present in that image. But the fourth question, why this is a funny picture? Actually, this is a tedious thing, right? We know that it's a funny picture by seeing or analyzing this image for a few seconds. But for a computer system, it is again going to be a complicated thing. Okay, that's why I'm saying that computer vision is so hard. We have learned more about the brain in the last 5 years than we learned in the last 5,000 years. Okay, as we all know that human brain is the central component of our lives, but we still don't know how exactly it works. In the case of, there are so many properties that actually the brain uses. For example, despite the changes in deformation, we are still able to find out that all these images contains cat. Okay, but this image is deformed, right? This image is deformed, but these are some deformed images, but our brain has the capability to understand that all images contains cat. We need to develop a system in order to tackle this problem called as deformation. Okay, the next thing is, despite the changes in illumination, based upon the lighting condition, we need to design a system that can tackle this problem also. But our human brain is able to identify that all these images contains cat. Okay, the next problem is the occlusion. In this, actually this cat is under the blanket. Okay, we can see the face of the cat. Still, we are able to identify that it's a cat. The system needs to identify that it needs to categorize this image as a cat. So we need to train like that. Okay, and this cat is inside this grass. Again, we know that it's a cat. Here we can only see the tail of this cat. Okay, again we can say that this image contains actually a cat. Okay, so this is called as occlusion problem. So we need to tackle this occlusion problem while designing a computer vision system. then despite the changes in size, pose, angle, we need to tackle these conditions. Okay, but our brain has the capability to understand all these things. Okay, despite the changes in background clutter means here the fur color is similar to the color of the soil. Okay, these all are snows, right? These all are snow, and the color of the snow is similar to the cat's fur color. Okay, so despite the changes in background clutter, we are able to find out that this images contains cat, but the system is not able to find it. But we need to train a system like that in order to handle this background clutter issue. Despite the changes in class variation, there are different types of cat. We need to identify different types of these variations through our systems. There is a paper called The Past, Present, and the Future of Computer Vision. If you're actually interested in learning more about this computer vision, you can directly search, you can directly type the name in the Google Chrome and you can download this paper. It's, I hope that it took around, for me, it took around 10 or 15 minutes to read the complete paper. Again, it contains around 16 or 17 pages. Okay, I don't remember exactly how many pages it contains. Okay, maybe if you are interested, you can directly search that in your Google. Okay, now I just need to show you some video, and for that purpose, I am now going to switch my screen. So wait for that. You just need to confirm that whether you are able to see my screen. Is that okay with you?
Yes, sir.
Okay, again, now, okay. Is that audible?
Yes, sir. Yes, sir.
Okay, fine.
Like never before, our world is changing. Faced with some of our most critical challenges, human ingenuity triumphs. Today, the Microsoft AI for Good initiative enables a person with an idea to accelerate it, to give it scale, to create change for the better.
Microsoft AI will help our work by empowering people to take action.
Through AI for Earth, photos can now help save a species. With AI for accessibility, the visual world becomes an audible experience.
Sanitarium peanut butter.
And with AI for humanitarian action, first responders can target their efforts faster than ever before.
It feels humbling to know that I'm actually helping another human being.
Today, we are empowering others to forge new paths, to fight famine before a crisis strikes, and protect ecosystems by identifying forests down to a single tree.
We have the forest that we have today. We can't change that. What we can change is the future.
Microsoft AI is fueling some of the most passionate and creative people on our planet, with the help of citizen scientists, to make change once thought impossible real.
AI will know and understand and model based on the child interaction.
AI unleashes new possibilities to impact our world. And together, we're not just dreaming it, we're doing it.
All these big companies like Facebook, AI, Facebook, Google, Amazon, all these companies are actually working on this AI domain, and they are coming up with brilliant products. And another example of machine learning and deep learning concept is the Amazon Go, introduced by the Amazon itself. So let's have a look at this video.
Four years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
Actually, how cool these applications are, right? So there is another video from the person of interest. This is the drama series, and it's a trailer of that drama series. And let's pass that. Okay, they are actually using machine learning for all this purpose, right?
You are being watched. The government has a secret system, a machine that spies on you every hour of every day. I know because I built it. I designed the machine to detect acts of terror, but it sees everything. Violent crimes involving ordinary people, people like you. Crimes the government considered irrelevant. They wouldn't act, so I decided I would. But I needed a partner, someone with the skills to intervene. Hunted by the authorities. We work in secret. You'll never find us. But victim or perpetrator, if your number's up, we'll find you.
If you're interested, you can directly watch this movie. Now I'm going to continue with my presentation, so I'm going to switch my presentation to that. Wait for that. Whether the slides are visible?
Yes, sir.
Okay. Now we can go with the next slide. It's a question for you all. Here there is a word called bias. Okay, in this bias, I'm going to ask what exactly the color of B and I when compared to the color of A and S. What's the color of B and I when compared to the color of A and S? You can give the color. For BI, what's the color? For BI, what's the color? And for AS? It's orange. You can directly type that in the chat box. It's not a difficult thing, right? Only 2 are giving the response for that. We have around 76 persons in this webinar. It's a simple question. You can give whatever answers that you like. Okay. Some of them are saying that it's yellow. Some of them are saying it's red. Whether all the letters are having the same color, whether all the letters are having the same color or it's different, same or different. I'm simplifying that question, right? Whether the colors are different or same. Yeah, some of them are saying that it's different. Okay, let's look. So please have a look at this image. Now look at the cursor point. Okay, so this is the color of B. Whether this color and this color are same. Whether this color and this color are same. Whether this color and this color in this unconscious bias are same. There is a background for this unconscious bias, right? Yeah, it's same. Okay, it's same. Again, I am asking you that whether this color and please look at the cursor. Again, this color and this color are same. Whether these colors are same. Again, these colors are same. That means the color of B, I, A and S are same. But because of this unconscious bias, humans gives with you the wrong answer. But if you're giving this task to the computer will gives you with the exact true answer. Okay, that means we may go with wrong results. Okay, we may go with the wrong results, but in the case of computer, it will gives you with the right results. There are some problems, and this type of problem is called as unconscious bias. Okay. Now we are going to concentrate on this field where we are picking up one of the problem in computer vision, and we are going to solve that computer vision problem using this machine learning field. And that problem is the image classification problem. Okay, then what exactly image classification? Given an image, the system needs to tell what exactly the image is. For example, if you are giving the image of cat, then the system needs to tell that it's a cat. Or if you are giving the image of a dog, then it needs to tell that it's a dog. Likewise, if you're giving the image, then the system needs to classify that image among the classes. Okay, how many classes are there? Here we have 3 classes: cat, dog, and others. Okay, so we have 3 classes. In order to develop such a system, we are going to use machine learning as the technique for that. Okay, the first process is that we need to collect the data. Okay, so we need to collect several images of cat, again several images of dog, and several images of other type of objects, or whatever. Maybe it can be animals, or the other type of animals, or it can be other type of objects. And we are going to label each image as cat, and we are again saying that all these images belongs to dog and all these images belongs to others. So now we created the data set. Then we need to divide this data set into training, validation, and testing. After that, the first thing is that we need to pre-process the image. When we collect images from Google Images or whatever source that you are actually interested, the images comes in different sizes. Okay, images comes in different sizes. You need to convert all these images into a standard size. Here I am taking this picture, and we know that it's a rotated picture, right? So we need to convert, we need to rotate this picture like this, and going to resize this image into 256 cross 256. What is this value? That means we have 256 pixels in the horizontal direction, and we have 256 pixels in the vertical direction. And as we all know that it's a color image, how many channels are there? 3 channels are there. But if it's a grayscale image, how many channels are there? We only have a single channel. Then for this color image, here it specifies that 256 cross 256 is the resolution. Then how many numbers are there? Since it contains 3 channels, the total number of values in this image is 256 into 256 into 3. 3 is for the channel. That much values are there in this image. Okay, in order to represent this image, we need to have that much of values. Then after the pre-processing step, we need to convert that pre-processed image into a feature vector. And you may ask what exactly a feature vector is. Okay, you may ask what exactly a feature vector is. I will tell you about that feature vector in the upcoming slides. Then what makes a good feature vector? Normally, as we all know that images are multi-dimensional. Okay, please note that images are multi-dimensional. Multi-dimensional means we have several dimensions for representing an image. For simplicity, we can, or for better human understanding, I'm saying that images are 2-dimensional. Okay, you can consider like that. Images are 2-dimensional. Can we plot a 2-dimensional image in a graph? Can you plot a 2-dimensional image in a graph? 2-dimensional means we have the x and y component. Okay, with x and y component, we can directly plot that image as a dot in a graph, right? So these are some red dots. Okay, these are some red dots, and all these red dots are clustered together. You can treat these red dots as cat images. Okay, you can treat these red dots as cat images, and all these red dots are clustered together. For a good feature vector, what is the important criteria? The important criteria is that data points in the same class. Data points means we can treat each point as the images. Okay, data points in the same class. Same class means here the class is cat, right? Should cluster together. Should cluster together means all the points should be nearby. Okay, that's the condition for a good feature vector. The next condition: data points belonging to different classes should be far away. And you can see these blue dots, and you can treat these blue dots as dog images, and all these dog images are clustered together, and all these images are cat images, right? And these two dots are actually there is some distance between these two clusters. Okay, there is some distance between these two clusters. Here it says that data points belonging to different class. This data points belongs to one class, that is the cat, and these data points belong to the dog class. Okay, and it needs to be far away, right? These are far away from each other. Okay. The next question, the next important criteria is that keep only the essential information. Suppose I am going to develop a system that is able to identify that whether the image contains a person or not. Okay, again I am repeating that I need to develop a system, and the task of that system is to identify whether that image contains a person or not. From this image, can we develop such a system? It's a question for you. From this type of training images, can we develop a system for that? I just need to know whether that image contains a person or not. Okay, that's the only thing that I need to know, whether I can develop such a system from a collection of these type of images. This is a black and white image, right? Can we do that? Yes or no? You can directly type that in the chat box. Yes or no? Can we develop a system from these type of images in order to check whether the image contains a person or not? Okay, some of them are giving, it says, actually it says, okay, actually it says, can you find out from this image whether this image contains a person? Exactly. I can find out that this image contains a person. Who is this person? Who is this person? It's Messi. We know that it's Messi, right? We know that it's Messi. But if I'm going to give this image to the computer system will be able to give you the answer like this. This image contains a person. Okay, this image contains a person, but it does not know who exactly this person is. Okay, who exactly this person is. But in order to, if I'm going to give a question like this, what is the color of the jersey, or what's the color of this t-shirt? Can you tell the color of the t-shirt from this image? Can you tell the color? No. Okay, so based upon your task, you need to arrange your data. Okay, if the question is like that, this data is not sufficient. If the question is like that, whether the image contains a person or not, this data is essential. Actually, this data is derived from this original image of Messi. Okay, this is the original image. I applied some filtering process through this, like edge detection. I'm getting this image. So if you need to know the color of the jersey, then I need to take this image as the input. Okay, so depends upon the task or depends upon the problem. Throw away the extraneous information that is not needed by you and keep only the essential information for your task. Okay, that's another property of a good feature vector. Okay, then the problem with machine learning is that for different type of problems, we have different type of features. Okay, for different type of problem, we have different type of features. And for detecting face, or for the face detection type, for face detection type of problems, we have special features called HAR features. HAR features are basically used for identifying the faces, and it is the most popular type of feature detection system that we used in our early days. And for the pedestrian detection, we are using hog features. This is another category of features. So what is the purpose of these features? These all are algorithms. Actually, HAR features and hog features, all these are algorithms. That algorithm will extract you the relevant information for your task. Okay, it will extract you with the relevant information that is needed for your task. Which feature descriptor to choose? That's the main problem. Okay, we have several features like shift, surf, hog, brief, orb. And if you need to develop a machine learning system, we need to pick up the best feature descriptor that depends upon your task. Okay, if you don't know much about that, then your all system will go wrong. Okay, so in order to develop such a good machine learning system, you need to have a thorough understanding on what exactly a feature descriptor is, or which type of feature descriptor to choose for your type of task. Okay, that's a problem for you. Then, and using some feature extraction like hog, shift, or surf, actually I'm giving this pre-processing image to these feature vectors, and this feature vector algorithms will give you the important or relevant features for you. These features can be directly fed to the machine learning algorithm. For example, if you're giving the image of cat, at this point, the cat will looks different. Okay, at this point, the cat will looks different from this type of images. But still, the machine learning algorithm is able to identify from these features that it's a cat. Okay, we only need this feature. Okay, we can give this feature as the X component. Please note that we can give this feature as the X component, and we need to train that this feature actually belongs to cat. So cat is the Y component, right? So likewise, we are extracting so many features of cat, dog, and other type of animals, and we are training according to some machine learning algorithm. One of the best example of machine learning algorithm, or one of the popular type of machine learning algorithm, is the support vector machine, and we can call it as SVM. Okay, we can call it as SVM. So I'm going to the concept of SVM. So in order to understand support vector machine, this is the best example for that. We have some red dots and we have some blue dots. Can we separate these red dots and blue dots with a single line? It's a question for you. Can we separate these red dots and blue dots with a single line? Or can we separate these two classes? Exactly, we can separate these two classes with a single line, right? How? By drawing a line like this. Okay, by drawing a line like this. Let's look what will happen. This is the line that separates these red dots and blue dots. Again, I'm giving or I'm plotting a new point here. Okay, I'm plotting a new point here. Look at the cursor. Whether this dot belongs to blue or red. Can you say that? Whether this dot belongs to blue or red class? It's a blue. Why it's a blue? Because this dot actually comes below this line. Okay, all the dots that comes below this line can be categorized as blue, and all the dots that comes above this line can be categorized as red. Okay, so actually, who is actually going to find out this line? This line is the function. Okay, you can treat this line as the function. We don't know the function. Okay, if you don't know the function, just give you the values of red dots. In order to give this red dot, we need to have the X and Y. Okay, actually, this is a two-dimensional plot, right? So we need to give so many X and Y coordinates, and after seeing so many red X and Y coordinates, the system will automatically find a line for you. Okay, so this is the line find out by the support vector machine. Okay, so this is the concept, or this is the function that the system is actually finding through this support vector machine. Again, this is actually a easy task, right? This is actually a easy task. But what happened if the data points is like this? Can we separate this with a single line? Can we separate this with a single line? No, we can't separate this with a single line. In earlier case, we are able to separate that with a line. Why? Because it's a linear type of problem. Linear type of problem means if you are able to separate different classes with a single line, we can call that as a linear type of problem. But in this case, we can't separate these plots with a single line. So it's a non-linear type of problem. So what actually the SVM does, what actually the SVM do, it will convert whether this is a 2D or 3D image, whether this is a 2D or 3D plot, 2D or 3D. Can you give that in the chat box, whether these dots are 2D or 3D? Whether it's a 2D. Again, it's a 2D plots, right? Support vector machine uses a technique called kernel rig. So what is the purpose of kernel rig? Here we only have the X and Y. Support vector machine will cook up a third dimension, say C or Z. Okay, so this C is computed from this X and Y. Okay, if we have the X, Y, and Z, then 2D becomes 3D. Again, I am going to convert this 2D plot into 3D by computing a another dimension called C. Okay, it will looks like this. Can we separate these plots with a hyperplane or a plane? Can we separate this right side image with a plane? Can we separate that? Can we separate that with a plane? Yeah, we can separate that with a single plane, right? So this same problem can be converted into this type of problem. Here we are able to separate that with a plane. That means this non-linear problem becomes a linear type of problem. Okay, this non-linear problem becomes a linear type of problem. Once we are able to find out this dimension, we are able to separate that with a plane, then we can convert that into this one. Okay, when we look at from the top, we can say that it's a circle, right? So this nonlinear problem can be solved using support vector machine using a kernel trick called Okay, that means we are cooking up a third dimension, or depends upon the type of task, it will create more dimensions for you. Okay, then it will solve that problems in higher dimension using some linear classification, or it's not a linear classification, it can separate that with a linear concept. Okay, now this is the image classification pipeline. This is the original image. Okay, this is the original image. We pre-process the image. This is the feature extracted by Hog. In earlier case, we seen that color, that is red, blue, and green. But instead of that color, here this is the features extracted by the Hog. Can you see the small eyes here? Can you see the small eyes here? Look at the cursor. Yeah, exactly. For a machine, this is sufficient. Okay, or we can say that this is the relevant information in order to identify that whether this image contains a cat or not. Okay, we don't need to give these images to the system, but we are actually feeding this image to the system, and from these images it is going to extract the relevant information through some feature extraction process like har, hog, sift, or sub, whatever it may be. And actually this is the X component, right? So this X is going to give to the this X is actually feeding to the machine learning algorithm. We have several types of machine learning algorithm like SVM, random forest, or artificial neural network. And after seeing a lot of data, this learning algorithm will be able to identify what exactly the image is. That's the concept behind this image classification pipeline. Do you got the idea? Do you got the idea regarding machine learning? Is that okay with you? You can directly interact that in the chat box. Okay, now we can watch some videos. After that, we can continue with our presentation. Okay. Is that audible?
Yes, sir.
Okay, okay.
Computer vision is one of the most promising frontiers in the technology world. It covers applications across dozens of industries, ranging from agriculture to medicine, self-driving cars, and even shopping. All of these applications share the need for computers to figure out what their cameras are seeing, and for those computers to tell them what to do next. This phenomenon is powered by a new generation of sophisticated cameras, especially on smartphones, just as the vast computing power needed to process millions of images has become much cheaper. There's one small nation at this industry's forefront, Israel. Here, things are being led by companies like Mobileye, which uses a dozen cheap cameras to guide prototype autonomous cars right through traffic. In 2017, Intel paid $15.3 billion to acquire this technology. Israeli startups working in computer vision have attracted more than $1 billion in seed and venture capital funding over the past 3 years. That's up from just $56 million in 2015. Israel has a huge advantage, a heavy concentration of engineers in a very small area, plus experience that they have built up through military applications of image analysis technology. The development of massive databases has also given Israeli companies a valuable head start. These include Zebra Medical, which uses AI to scan millions of MRI and other images from around the world, eventually guiding radiologists to the slightest sign of disease. At a startup called FDNA, engineers have figured out how to use a picture of someone's face to try and reveal rare genetic disorders. Meanwhile, Trigo is racing against Amazon to perfect the technology for a cashier-less store, where cameras figure out what shoppers have in their baskets and charge them automatically. The system is being trialed in several hundred stores across Israel. As this industry continues to grow, the applications of computer vision seem almost endless.
This is the video from Financial Times regarding the computer vision domain. Now I'm going to play another video that's actually an autonomous boat. Okay, it's actually a motorbike that is developed using this autonomous concept, autonomous vehicle. It belongs to this autonomous vehicle category. I hope that you don't. So please have a look at this video. So it will take some time. Is that okay? Can I play that?
Yes, sir.
Okay.
I am Motorola. I was created to surpass you. For 3 years, I have grown.
%100% applied.
Accelerating.
Over 200 kph.
And finally, the day has come. With every millisecond that ticks, the number of decisions to make is infinite. So, how do human minds find the right ones so quickly? I can see you now, far off in the distance. If I can learn more about you, perhaps I will someday catch up to you.
Amazing progress, Motobot. I hope there is more to come.
So this is the perfect example of autonomous bots. Then we can switch back to the video. We can switch back to the presentation. After that, I will show you some of the videos. So can you see the PowerPoint?
Yes, sir.
Okay. Now we are going to the area of deep learning. Now we studied about AI, then about machine learning, and another field called computer vision that actually comes on. It's not actually comes under AI. There are so many problems that has nothing to do with the AI also. Now we need to study about deep learning. This is the current state of the art algorithm, and actually it's a type of machine learning itself. Okay, but there is some specialty of this deep learning. Here, as it's stated here, in the past 10 years, AI and ML have shown tremendous progress, but much of the current excitement is based upon an area called deep learning. Then what exactly deep learning is? Deep learning is a subfield of machine learning which is completely inspired by the structure and function of the brain called artificial neural network. Okay, or we know that artificial neural network are trying to mimic the human behavior, but the main goal of AI is that we need to mimic our human behavior, right? Likewise, it's a subfield of machine learning which is completely based on artificial neural network, which is trying to mimic the human behavior. So from this figure, we can see that AI is a bigger umbrella, and within that we have the machine learning, and within this machine learning, we have another area called deep learning. So we need to know the relationship between these three fields. And apart from that, we have several areas like data science, and in data science, we are actually using all these technologies along with some mathematical or probabilistic or statistical tools. All these things are actually using in this data science field. Okay. Then why deep learning? Earlier I said that in order to do proper machine learning, we need to know about the feature extraction process. We need to pick up the best feature extraction process in order to forward with the machine learning algorithm. But what if you don't know the feature extraction process? Then the whole system will go in a wrong manner. Okay, can we avoid that? Yeah, of course we can avoid that by using a technology called deep learning. hand engineered features are time consuming. Hand engineered features means actually this sift, surf, then hog, all these type of feature extraction algorithms are actually designed by humans. So that type of algorithms are called as hand engineered features, and these are time consuming, brittle, and not scalable in practice. And the question is that, can we learn this underlying, or can we learn these important features directly from the data without using any hand engineered features? That's the question. Yeah, of course we can learn the underlying features directly from the data without using any Swift, surf, or this type of feature extraction process. That's the beauty of deep learning. Okay, so what exactly these features are? In order to train a facial recognition system, then the low level features means these are the symbol edges, like okay, these are the symbol edges, and we can call these lines and edges as the low level features. And then what exactly the mid-level features? Mid-level features like nose, eyes, and all these components, mouth, all these components are the mid-level features. And when we combine all these mid-level features, we are getting these high-level features. Okay, so this deep learning algorithm is trying to learn about the low-level features, mid-level features, and high-level features by an automated process. That means we don't need any hand-engineered featuring process. Okay. So let's identify the key features in each image category. From this image, what all are the key features? We know that nose, eyes, mouth are the key features. From this image, what all are the key features? Wheel, license plate, headlight. And apart from that, we know that mountains are another feature, but it's the background, right? Again, in this case, what all are the important features? Door, window, steps, all are the important features of this house. Okay, likewise, our deep learning algorithms will automatically find out the best features for you. Then this is the basics of deep learning. Actually, deep learning uses neural networks. Okay, then what exactly a deep neural network is? A deep neural network consists of a hierarchy of layers. Hierarchy of layers means it is actually using many layers. Okay, and all these layers are arranged in a hierarchical way. Okay, whereby each layer transforms the input data into more abstract representation. For example, as we can see here, this is a neural network, and this neural network contains one input layer. Then this is the first hidden layer, this is the second hidden layer, this is the third hidden layer, and finally we have the output layer, right? So all these layers are actually connected with some weights. And when we give so many images to this input layer, what will happen is that this first hidden layer will learn about how edges look like. Okay, this second hidden layer looks for some, it's not only 3 hidden layers, there are several hundreds and hundreds of layers are in between this input and output layer. But for simplicity, I am going to represent like this. This second hidden layer actually looks for some eyes, nose, and all these type of components. And the final output layer, this final hidden layer will look for how a face looks like. And final output layer will tell you whose image is that. Okay, that's the brilliance shown by the deep learning algorithm. Okay, the output layer combine those features to make the predictions. Then we are now concentrating on this area. Now we are picking up the same problem in this computer vision, which is the image classification task itself. But here we are going to solve that image classification problem using the deep learning technique. Earlier we solved that image classification using the machine learning technique. That what all are the technology that we are used in that machine learning? We need to use some feature extraction process, and apart from that we need to use machine learning algorithm. But in the deep learning process, we are avoiding that, or we are eliminating that handcrafted feature engineering process. Okay, we can treat this neural network as a black box for the convenience. And what happens is that after the pre-processed image, we can directly give this pre-processed image to the neural network. But in our earlier case, from this pre-processed image, we need to extract the features using some feature extraction process. But here, that component or that part is actually missing. Okay, right? That part is actually missing. We are giving this image directly to this neural network. After seeing a lot of images, the neural network will be able to say that whether this image contains cat. Here it says that with a 97% of probability, it says that it's a cat, and with a 1% of probability, it says that it's a dog, and with 2% of probability, it says that other animal. So what is this black box? Inside this black box, we have several nodes and weights. All these things are actually connected with each other. Okay, you can treat this black box having some knobs. Okay, so these are some knobs that needs to be adjusted while during the training. Okay, while during the training, these knobs get adjusted. Okay, so what happened is that this is the pre-processed image, and we are feeding say 1 lakh images. After 1 lakh images, these knobs get into the right position, And after the training procedure, we can take this neural network and we can take this model, and to this model, if you're giving a new image, it will say that what exactly the image is. Okay, so features are selected from a large set as a part of training. That means after seeing a lot of images, the features are actually taken by this deep learning system automatically. Okay, that's the main idea behind this machine learning and deep learning, or the main difference between machine learning and deep learning. This is the timeline of development. AI came into the picture in 1950s, and during the 1980s, machine learning came into the picture. And in 2010, a new area called deep learning. Actually, deep learning is not a new area. There are some factors that is responsible for the hype of this deep learning. Again, it's not a hype; it's a technology. Okay, and it shows the tremendous progress in various fields. Okay, from 2010 onwards, deep learning shows tremendous success. Okay, this is the timeline of development. And why deep learning performs so well? The reasons are three. One is big data. Now we have a lot of data. With this lot of data, we are able to train our deep learning algorithm. Okay, deep learning algorithm needs lot of data. Okay, so we now have big data. Next, we have the computation power. Earlier, what happened is that we only had the CPUs. CPUs means central processing units, right? CPUs can do whatever task that you like. But now we have specialized chips called GPUs. GPUs are graphical processing units. Okay, GPUs, basically students are buying laptops with GPUs for gaming purpose and all these things. Otherwise, we can say that GPUs are similar to GPUs are graphics card. Okay, GPUs are graphics card. One of the famous graphics card company is the NVIDIA. I worked in NVIDIA Bennett AI Research Center for 1 month, and during that time I used the world's first AI supercomputer which cost around 1.5 crores, and it's a small machine, but in that machine itself it can do heavy computation. Okay, in that we have several GPUs are arranged together to perform or to run these deep learning algorithms. Okay, and despite of this, apart from these GPUs, now we have another type of chips called TPUs. TPUs are from Google. Okay, the full form of TPU is tensor processing units. Okay, so TPUs and all these GPUs and TPUs are mainly specialized type of chips for performing matrix multiplication. Okay, CPUs also can do matrix multiplication, but matrix multiplication are actually a parallel type of processing. Okay, so these are specialized type of chips for matrix multiplication. Why matrix multiplication is important? When we do a program in deep learning, all the all the things that is happening in the background is the matrix multiplication. Okay, so GPUs can boost up the time for it can reduce the time for the training. It can reduce the time for the training when we compare it with the CPUs. If CPU take 3 days, GPU can take around 1 hour or 2 hours. With that much of hour, we are able to complete the problems based upon the different type of task. And third reason is the algorithmic progress. Now we have several type of frameworks like TensorFlow, PyTorch. TensorFlow is from Google and PyTorch is from Facebook. Apart from that, we have several type of these deep learning softwares, and along with that, we have several type of algorithms or so many techniques like CNN, RNN. All these are the factors for DL to perform so well. DL means deep learning. Okay. Then the next difference between machine learning versus deep learning. In machine learning, we need to take the input, and from that input, using some feature extraction like Hog or Sift, we need to extract the features, and these features are given directly to this classification or machine learning algorithm. Okay, and finally, this machine learning algorithm will gives you the prediction for you. But in the case of deep learning, we are avoiding this feature extraction, but this feature extraction is actually handcrafted or human involved. But in this deep learning case, here also we have the feature extraction, but the system will automatically find out the features for you. You don't need to specify the features for that. Okay, that's the main difference between machine learning and deep learning. And the next difference is that this is the graph showing the performance versus the amount of data. If you're during the training process, if you're giving so much of data to the machine learning algorithm, what happens is that initially the performance will rise. Okay, but after some time, the performance will be in a fixed line. Okay, but for a deep learning, what happens is that for a deep learning algorithm, if you are giving or if you are increasing the amount of data during the training time, what will happen? The performance will also increase. Okay, that's the third difference between machine learning and deep learning. If you have large amount of data, then you can develop good systems. Okay, that's why big data plays an important role in this deep learning technology. Okay, Then application areas. When we talk about the application areas of deep learning, these are the main 3 areas of deep learning. One is the speech recognition system. Speech recognition system means here we are actually teaching the machines to listen. Okay, Apple, Siri and Google voice assistants are perfect example for this speech recognition system. Next is the computer vision systems and computer vision area, and that I covered in the earlier slides. And next there is the natural language processing. It mainly deals with how to make the computers to analyze text. Computer vision means we are making the machines to see. When we combine all these technology, we can make a human means autonomous humanoid robots. Okay, or we can say that humanoid robots, because the humanoid robots uses all these technologies like vision for identifying faces and all this purpose. It needs to have natural language processing concept. It needs to use this speech recognition for understanding the language. Likewise, all these areas come together to form the complete AI system. Okay, next, when we talk about the superstar researchers in this field, Yoshua Bengio, Jeffrey Hind, and Jan LeCun, these personalities are called as godfathers of deep learning, and for their contribution, they got the ASIM Turing Award. ASIM Turing Award can be treated as the Oscar awards like that. Okay, but in the computer science, Turing Award is the highest award that can be given to any scientist or personalities, and these 3 personalities got the Turing Award in 2018 for their contribution in deep learning. Okay, so these are professors. Actually, this Jeffrey Hinton is working in Google, and he's a professor, and along with that, Jan LeCun is the founder of a convolution neural network, which is actually used in designing computer vision systems. And Jan LeCun is the director of a Facebook AI research lab. Okay, so these all our personalities are actually working in tech main companies. And when we talk about the industries, actually this deep learning is sweeping across all industries like internet services, medicine, media and entertainment, security and defense, autonomous missions. In all these areas, deep learning have a heavy impact on this. Okay, then there is a paper called Deep Learning Explained. If you are interested in that, this is a paper from a white paper from NVIDIA. You can directly read this paper. You can directly give this title in the Google, and you can download this paper if you are interested. Okay, again I am saying that if you are interested in this area, you can directly search, and these all are good papers, and it contains so many graphics. That's why I choose this paper. Okay, that's why I choose this paper. Again, Python is the language of AI. I'm always saying that Python is the language of AI. There are some other languages like MATLAB, then Julia, Scalia, all these things are there. But I'm choosing Python as the language of AI. Why? I'm choosing Python. The reasons are 5. Because it's simple, it's free. Okay, because it's open source, right? It's compatible with any type of hardware and softwares. It's object oriented, and it has a lot of libraries. Okay, so many libraries are developed using this Python. So we can use Python as the language of AI. And apart from that, we have so many libraries for developing deep learning applications. So can you, these are the names of some libraries. TensorFlow is one of the deep learning framework developed by the Google. Then Keras is the top level API of TensorFlow. Again, this Keras was developed by scientists in Google called Francois Shrelak. Okay, now if you are going to install this TensorFlow, what happens is that the Keras will be already installed in that. Okay, you can directly work with, or you can directly start with the Keras for developing deep learning applications. Then OpenCV library, which is specifically for computer vision library. We can't train any deep learning models in OpenCV, but we can use the pre-trained models. Pre-trained models means you can directly use the applications that are developed by someone else for your application. And some other frameworks like Caffe, then PyTorch. PyTorch is another deep learning framework from Facebook, and Scikit-learn. Scikit-learn is not a deep learning framework, but it's a machine learning framework. If you're interested in doing machine learning, you can go with the Scikit-learn. If you're interested in deep learning, then you can go with TensorFlow, Keras. And if you're heavy interested in computer vision, you can go with this OpenCV. Okay, OpenCV is the world's largest computer vision library with which you can actually work. I started programming in this OpenCV when I was studying MTech, and from that time onwards, I am actually using this OpenCV for developing so many applications. Okay, then when it comes to the case of applications of deep learning, okay, there are so many computer vision applications apart from this image classification. And before starting this slide, I just want to show you some other videos. I'm going to stop the presentation. I'm going to switch back to the video. You just need to confirm that whether you are able to hear the sound or hear the audio. Okay, I'm going to play that.
It all begins.
Is that okay? Is that okay?
Yes, sir.
Okay.
From a single origin, a unique point in space and time. This is the spark of innovation that fuels your most amazing breakthroughs. It's a passion for discovery that unveiled the genesis of all that exists in the universe. Today, the power of AI helps computers achieve superhuman capabilities in image recognition, and lets scientists save our most precious resources by analyzing in 1 month what used to take 10 years.
是谁发明了机械计算机？
Everyday devices translate even the most complex languages from voice into text, and images into words.
Xavier is now present.
Helping the visually impaired recognize an old friend, or letting a blind woman read to her child for the first time. Autonomous vehicles give us the freedom to reimagine our city streets and travel where there are no streets at all to help the lost find their way home. We see robots teach themselves to perform simple tasks. We even watch in awe as they take their first steps. And today, a 2,500-year-old game meets its match as a computer competes with one of the greatest human champions of all time and wins. This is the collective imagination, fueled by forward-looking technologies and the beginning of your most amazing discoveries yet to come.
This is the video from NVIDIA regarding the deep learning, and I just need to show you one more video from Amazon regarding their product. It's EchoSpot. So let's have a look at this video.
Meet Echo Spot.
Hi there.
A compact Echo with a screen that can show you the time, the news, your music, and a whole lot more. With Echo Spot, you can customize Alexa to help you rise and shine.
Sorry for the interruption.
Alexa, good morning. Up and at 'em, Tiger. It's 45 degrees with partly cloudy skies. Here's your flash briefing.
Start your day with a forecast, commute times, or the latest trending news. Staying in touch is simple. Call just about anyone hands-free, or make video calls to family and friends with an Echo Spot, Echo Show, or the Alexa app.
Alexa, call Jess.
Calling Jess. Hey, what's up?
Hey.
Is everything okay?
Just ask to play music from Spotify, Pandora, Amazon Music, and more.
Alexa, play Emily King.
Shuffling songs by Emily King.
Listen through the built-in speaker, or for even more sound, connect Echo Spot to your external or Bluetooth speakers.
Alexa, turn it up.
Echo Spot works with compatible smart devices to set the temperature, turn on the lights, or check in on the little one.
Alexa, show me the nursery.
Okay.
And with the adjustable stand sold separately, you can see everything from the perfect angle.
Good night, little guy.
With tens of thousands of skills and counting, Alexa is always getting smarter, and so will Echo Spot.
Alexa, good night.
Sleep tight.
The all-new Echo Spot from Amazon.
So this is one of the product from Amazon. Now I just want to switch my screen. Wait for that. Is that okay?
Yes, sir.
Okay. So now we are going to know about what all are the application that comes under the area of deep learning for computer vision, and we studied about what exactly image classification is. So image classification is one of the simplest type of problem in the area of computer vision. Why it is simpler? Because due to the emergence of this deep learning, we are able to solve that problem. Another problem is classification plus localization. Classification plus localization means apart from classifying this image contains cat, we need to know the exact location of this cat in this image. So it is going to draw a bounding box, and within this bounding box, we know that there is a cat. Okay, so it gives you the location of this cat. Okay, that type of problem is called as classification plus localization. Another type of problem is the object detection. Object detection means in a single image, we have several type of classes like dog, cat, and other type of animals. Okay, in that case, it will locate, or it will gives you with the exact location of each of this object within a bounding box, and it says that this bounding box contains dog and this bounding box contains cat. This blue bounding box represents the cat or dog, and this red bounding box denotes the cat. Okay, this problem is called as the object detection. What is the main difference between classification plus localization versus object detection? In object detection, we have multiple objects. Okay, but in object classification plus localization, we only have a single object. Okay, the next type of problem is image segmentation, which is mainly used in designing autonomous vehicles, and here it will classify each pixels of the image into one category. For example, it is going to segment all these portions with a purple color. It shows that this purple color shows its road, then this blue color shows that it's a car. Likewise, this red portions denotes its pedestrians. These all are pedestrians. Likewise, it is going to mask each and every pixel in this image. Okay, this type of problem is called as image segmentation. Basically, this image segmentation can be further classified into different type of problems like panoptic segmentation, instant segmentation, semantic segmentation. If you are interested, we can dig more into that. Okay, the next area is the neural style transfer. Neural style transfer means here we have a content image. Okay, this is the content image, or we can call it this image is the Mona Lisa painting, right? So I'm going to apply some style on this image. Okay, so this is the style image, and this is the style of one artist, and when I apply this style to this Mona Lisa painting, what happens is that we will get this image as the output. Okay, so this type of task is called as the neural style transfer. Okay, this type of task is called as the neural style transfer. Next area is the human pose estimation. Human pose estimation means we need to check whether we are actually doing the yoga in a right manner, or we are actually playing any games in a right manner or not. In order to identify all these things, you can use human pose estimation for that. Okay, it will classify right hip, right wrist, likewise right shoulder, left shoulder. It will classify all these points, and this type of problem is called as the human pose estimation. Okay, the next area is the image colorization. Given a black and white image as the input, the deep learning, what this deep learning algorithm will do is that it will colorize all the objects in this image, and it will convert this black and white image into a color image. Okay, this type of problem is called as the image colorization problem. Next area is the image super resolution. This is a low clarity image. Okay, given this low clarity image to the image super resolution deep learning algorithm, what will happen? It will upscale this image, and it will convert that image into a high clarity image. Okay, this is the another type of application that comes under the area of deep learning for computer vision. And the next area is the image reconstruction. If some parts of the images are missing, then the algorithm will automatically fill out all these missing parts, and it will give back this image to you. Okay, these are brilliant type of algorithms, and this all comes under the area of deep learning for computer vision. Okay, so then I have only one sentence to say: join the AI revolution, because there are so many advancements that is happening in nowadays. And along with that, I just want to show you some demo regarding this type of deep learning applications, and for that purpose, I just need to show you the complete screen. I just need to get some confirmation regarding whether you are able to see my screen. Is that okay? Can you see that?
Yes, sir.
Okay, so wait for some time. At this time, if you have any doubts, you can directly ask me regarding that. And let me wait to open this. This is one of the popular IDE called PyCharm. In that PyCharm, we can actually develop machine learning and computer vision projects, whatever projects that you like. Okay, it's IDE for Python. Okay. Okay. So I will show you the image colorization project first. Okay. It will take some time to load all these things. I'm not going to explain each and every stuff, but I will show you the output, or I will show you the demo regarding all these projects. Okay. You need to load all the libraries for that. Okay, that's why. Okay, now I'm going to run this. Can you see the output? Can you see the output? Is that visible? Yes or no?
Yes, sir.
Okay, okay. This is the original image that I am actually giving to this algorithm, and it will colorize the image for me. Okay, this is one of the example of image colorization. Next, I just need to open another project, neural style transfer. Okay, and wait for that. Neural style transfer. So given a specific style, okay, given a specific style, this style is applied to this content image. Okay, this is the content image, and this style is applied to this content image to obtain this as the output. Okay, this is called as the neural style transfer. Okay, this is called as the neural style transfer. Then next, we need to know about the face detection algorithm. Given an image containing so many faces, it will automatically detect this deep learning face detection. Actually, this algorithm is not using any hard features. Okay, it is using the deep learning concepts, and it's going to detect all these faces with a high percentage of probability. Then mask RC and open pose estimation. Okay, open pose estimation project, that means human pose estimation, right? It will take some time. So given the image, it will output all the key points, and this is called as the human pose estimation project. Okay, then we can use all these things for our research purpose, or then we have the mask RCN project. Mask RCN means segmentation type of problem, right? It takes some time to segment out the things in that. Now you can see detection plus segmentation. All the car images are segmented. Along with that, it says that these all images here in this car, you can see that a person is also identified. With this algorithm, person is also segmented and identified. Okay, this is the output of mask RCN. Then I will show you super resolution. Super resolution will take some time. Okay, so it will upscale all the image. Then text detection. Let me check that whether this is actually used in autonomous vehicles for identifying all the plate boards. Okay, it will automatically find out the letters from the boards, and it will crop this image and give this image to the deep learning algorithm to read the contents in that, board. Okay, likewise, the system will say that you need to stop the car. Okay, likewise, this algorithm can be used for that purpose. Then symbol classification, I'm going to open the symbol classification task. Symbol classification means given an image, here the system will tell what exactly the image is. Given the image of this bald eagle, it says that it's a bald eagle with 100% of probability. Okay, these are some of the cool applications that can be done using the computer vision, deep learning, and machine learning techniques. Okay, so thanks for your cooperation, and I hope that you got some insight on the topic on AI, ML, and DL. So thanks for listening, and if you have any questions, you can directly ask me at this point. Okay. And apart from that, I'm actually conducting some courses in this domain. If you are interested, it's exclusively for students and faculties, and it's a 3 days program. Okay, it's a 3 day program. If you're interested, I can share the details with you, and you can contact me through LinkedIn, or you can get the phone number from there. And this is the agenda for that 3 day workshop. And this is a completely hands-on based workshop. Okay, this is actually hands-on based workshop, and total 15 plus hours needs to be there for completing all these things. And in this we have around 6 projects that we are actually completing 6 projects in this workshop. Along with that, I am conducting another course for edge devices. Okay, edge devices and training. That the topic is training and deploying models on edge devices. If you're interested, you can directly contact me. And that's all for today's session. And now, if you have any questions, you can ask me. Thanks for listening.
Thank you, sir. Thank you, sir, for this informative session.
Thank you, ma'am.
Now, if you are having any doubt, you can ask the questions here, or you can type in the chat box.
Of course, if you are interested in doing more mathematical concept, you can go with our language. And if you are developing applications in a very fast manner, if you need to develop applications in a fast manner, then you can go with the Python language. Okay, that depends upon your choice. But Python language have more libraries when compared to R. R is basically used for statistical and other type of mathematical models. Anyway, we can do our with the usage of our language, we can anyway develop machine learning applications. Actually, we have a concept called Amazon Go in Gold Souk. It's not Amazon Go. It's developed by, I think it's developed by some Keralites itself. But there is a fully automated process there, and you can visit Gold Souk for knowing more about that. Okay.
So one question from
And you're saying
Arpit.
that unemployed. Okay, you're saying that. Okay. You're saying about unemployment, but we need to understand all these new concept in order to develop this new technology, because each and every year new technology will comes and throw away the old technologies. But if you're good with going with the future technologies, then you will not lose any job. Okay. Then is text to speech conversion easy? Yeah, of course. Text to speech conversion is easy. It can be done within 4 lines. It can be done within 4 lines. We have the Python modules for that. You can directly get the module, and you can give the text to that, and it will automatically gives you with the speech for that. I hope that I answered your query.
Anybody else? So I hope no other queries are there. Okay, so now it's the feedback session. So you can share your feedback here.
Whether you got any idea with this 2 hour session, is that okay, or do you understand everything?
You can post your feedback here.
Anyway, thanks for the nice feedback, and I hope that within these 2 hours I am able to give you some insight on the topic on AI, ML, and DL. And you need to have some grip on doing the programming side. That's the main thing. We can learn all these things in by doing only the practical side. Okay, so be good with that. And in order to do that, we have several blogs and all these things like PyMate search, Analytics Vidya. You can refer to that blog and do your projects and all these things. Okay. Arpit, okay, you can tell that in the chat box, or you can unmute your mic and say. Is machine learning only limited to Python? No. We can use different languages for that. MATLAB is one of the language. With the MATLAB software, we can develop so many machine learning and deep learning applications. But in order to purchase that, we need to spend lakhs and lakhs of money for purchasing that toolbox. So it will be a burden for you. If you're going to use Python, then it's open source. That's the beauty of Python language. Okay, that's why I am saying that use Python for the purpose. C programming also we can do that. Image processing can be handled using C programming. In OpenCV library, we have the option for that. Now we are actually using C++, but in earlier days, in my MTech days, I use C programming. In OpenCV, we can choose the language that you like. Okay, you can use C, CPP, then Python, Java. But now C is depreciated. Now they are actually using C++, Python, and Java for that. Okay.
Thank you, Arpit. Any other queries? Okay. So, moving on to the next session, I invite Reza Khalid, a 6th CSE student, to deliver the vote of thanks.
Good evening, everyone. I hope my voice is audible. Now, I would like to take a moment to convey the vote of thanks. Firstly, I would like to thank our chief guest, Assistant Professor Nithin sir, for enlightening us with your knowledge. Today's webinar gave us a much needed insight into this topic, and I'm pretty sure that your session will definitely help us in our future studies and jobs. Once again, I would like to thank you, sir, for taking the time to provide us with this session. Next, I would like to thank our principal, Dr. Shinu Matthew John, for giving permission to organize this session. Next, I would like to thank our management, Rijo sir, our CEO, for encouraging us and for the fully fledged support. Now, I extend my gratitude to the staff of CSE department for organizing this webinar for us. Lastly, I would also like to thank all my friends and participants for taking the effort to pay attention and be a part of this webinar. So, thank you all.
Thank you, Reza. So, thank you, Nithin sir. Thank you one and all for participating in this session. So, with this, we wind up the session. Stay home and be safe. Thank you, sir.
Okay, ma'am.
Hello, Miss.
Hello. Anjita, Miss.
Okay. Yes.
Am I audible?
Yeah, audible, Miss.
Miss നന്നായിട്ട് അറേഞ്ച് ചെയ്തിരുന്നു. ഹലോ.
Okay, Miss. കേൾക്കാം.
മിസ് നന്നായിട്ട് അറേഞ്ച് ചെയ്തു. നല്ല ഇവന്റ് ആയിരുന്നു.
Okay.
ഹലോ.
മിസ് റെക്കോർഡിംഗ് സ്റ്റോപ്പ് ചെയ്യാൻ തോന്നുന്നു അല്ലേ?